Right. Here. Now I'm unmuted. Is that working? Okay, cool. Thank you. Yeah, I'm sorry. I hope that they're not suffering too much. Okay. So hopefully we'll get through these technical problems as we go. So in the meantime, the main for communicating is on Slack. There is a group where you want to post general questions. Sorry, a channel. And I have channels for the lectures and for the assignment, so that we don't mix up questions, especially for the assignment, because otherwise it's difficult to search around. All the required readings are available online for free at the USC library. And you have the links from the slides. I have some optional reading. It's up to you if you want to look at those or not. So I'll be starting with the part of the course, unless there are questions that have to do with the organization. Okay, so let's start with a definition of data visualization. So in data visualization, we have use these for short. So the data part, I think that's what you're most familiar with. So when we refer to data, it's really something that is abstract in general, and that is in relation with different layers of how the information in the data is structured. So if you just take the word data, singular is data, it is one bit of data. And that can be anything, a number, a string. And so taken outside of context is very difficult to attach any type of meaning to it. As soon as you start assembling it, different bits of data together, you end up with a kind of grammar where you build a sentence. And that leads to information. That is something that you can actually use in your daily life. So yeah, I have an example that I'll go through in a moment, but if you move up in terms of complexity of the information, then you end up to the level where you know how things work. And the next level is where you are able to do prediction. So that's the part that you're also familiar with, where you apply machine learning to basically model data and be able to understand how it's going to behave in the future. So the little example that I had has to do with the Griffiths Observatory that is nearby. And that's a sentence that I took from the website that explains that the observatory is open on Tuesdays to Friday during noon to 10 p.m. Admission to building and grounds is always free. So every piece in there is a bit of data. Taken in isolation, they're not very useful. But as soon as you string them together, then you have an information that allows you to make a decision that is, when are you going to potentially go and visit the observatory? And you understand also what the cost that is related to it. So the knowledge comes in where you understand some deeper patterns in the data. So typically when people spend most to go and visit museums, and so that might not be a good time for you to do the same. So if you want to enjoy the location without the crowds, then you'll need to acquire this knowledge. So you need to understand what are these patterns of people visiting the location. And that's the knowledge part. The wisdom, we can, to give you an example, also from the slides, if you want to predict how long it could take you at the time that you've chosen to go and visit in terms of travel time, then you really need to understand what are the patterns of traffic in the city, which can be very complex. And that leads you to basically be able to predict the travel time. So if you do it starting now, then it's obviously easier to do than if you want to do a prediction where you're going to go in a random day, say in 2 months from now, because anything can happen. So the traffic patterns on weekends are different than what they are during the week. If there are accidents or if there are events on that day that may impact you. So this level of wisdom is the most refined kind of version of the information pyramid that we've been described, and that starts with data, and that goes up to information, wisdom, and I forgot the one in the middle. That is the knowledge. So this is called the DIKW pyramid. So you can put it in the form of a pyramid where it's more refined to the top in terms of the quality of the information that you have. And that's basically what we have to work with in terms of visualization. Now, when you think about how you use visual data in data science, and I have also a picture that is on the slides. Obviously, hopefully you can see it. This is in slide number 21. So here we have acquisition. I called it access, but it's basically the same thing. Analysis and okay, so in this picture, we're basically looking at the typical data science pipeline. So you start from data here that you collect from the real world. You do some acquisition, which means that you're going to collect this data in some way. Eventually put it in a system in a format that allows you to access it, so that you can analyze and you can enable people to make some decisions based on it. So if you look at this picture and you think where data visualization is useful, it's going to be basically all the boxes. In acquisition, that is because most of the time when you are working with data, you're not familiar with the type of data that are out there. And the reason is that the systems that produce the data keep changing and evolving. And they tend to be very complex, displaying all the features that you have in big data. That is that they might come very quickly. They might be of different types, and you need to use them together to make sense of it. But also, they may display some characteristics that you don't want to factor into your analysis models, and that is noise. So a lot of time you have data that are noisy, things that are really not useful to store, and that might adversely impact your decisions. So if you model based on some random noise, obviously you're going to have some random outputs from your predictions, and that's not very good. So there you want to start visualizing your data at the raw level, as raw as possible, to understand it. And that's one place where data visualization is useful. As soon as you store it, then if you want to let others access the data, you need to physically communicate this information to them. And depending on the type of data-based system that you're using, you may do this in different ways. So if you have a relational database, then you will want to show a schema to somebody who will need to use it. If you store it in a non-relational database, then you still need to explain to people how you access the data, and there you might want to think in terms of visualizing maybe the APIs that allow you to access the data. The analysis thing that you're most familiar with, and that's what people think first in terms of data visualization, because their data visualization is going to allow you to reveal some patterns that are in the data that might be useful for you to model. And the last box is the action. And there, really, the purpose is to try to make it easy for people to use the output of your models, but also for you to understand what is the performance of your models. You may want to visualize it. So all those obviously are prime application of the in this whole data science pipeline of visualization. So the units that taking one step back here of data and information are based on bytes, where 1 byte is 8 bits. And we often hear talk about things such as terabyte, petabyte, exabyte, zettabyte, and others. And that is because we have more and more data to work with. And oftentimes, when you start visualizing the data, one of the first things that you want to understand is how much of it do you have, because most of the displays that we're able to create need to fit into the screen. You have that many pixels, and you're not going to be able to put more information than what you have in terms of real estate on your screen. So once you make that determination, then you have different choices. You can try to summarize the data, for instance, to get some number, and take it from there. If it's too much, if it's, or you can just slice it and see one part of the data at the time, or look at the distribution of the data and so on. So I have a little recipe there on how to understand these numbers, in particular the zeta byte, might not be familiar with those, and it is very difficult conceptually to try to understand what these powers of tens of bytes are. So the way I work it out is based on the symbol and the prefix that is associated with each one of the values. So tera, you're familiar with the terabyte. It's related to the Greek word that means 4. Beta is related to 5, exite is related to 6, zeta to 7, and iota to 8. And those you can translate from one to another by looking at powers of kilobytes. So 1,000 to the power of 4, 5, 6, 7, 8. And then you can translate from one to the other. So I have a little exercise there with the square kilometer array. I still don't know if this went online, but that is collecting 10 petabytes of data every hour, so that you wrap your mind around what these quantities are. So I'll let you play with that. If you have questions on those calculations, we can go over it in the next session. Obviously, for the quiz, I might ask you to do a translation from zettabytes to petabytes. So we looked at the data visualization. We looked at the first part, and we didn't finish up with the second. So if you don't mind, I'll go another 5 minutes, and then we'll take a break, okay? So the data part, I think we kind of covered. The second part here is the visualization. And obviously you're going to ask, why are we talking about visualization or hearing things? And the reason is that the bandwidth that is associated with our eyes is the greatest by far among all other senses. And obviously that means that you're able to take in as much data as your eyes ideally would allow. And that bandwidth, if you look at the graphic on the slide, is equivalent to what you get in terms of your internet connection at home, which is pretty good. However, if you look at the definition for data visualization and information visualization, that again is a refined version of the data visualization, then you'll see that they tend to talk about reinforcing human cognition, and that has to do with the fact that even though we're able to see a lot, our brain only can process a finite amount. And so it's important to understand those mechanisms so that you can rely on it in order to create efficient visualization. Now the graphic that you see in slide 27 that is the boundaries of senses. It looks like this. Has a little white square here at the bottom, and here is this is anything that is visual. That is, it's actually bigger than this. So it's your broadband connection at home. But the little white square there is what you are aware of at any point of time. So this is what your brain can process of this entire blue area of information. And that means that when you create complex displays, you can put a lot of stuff on it, but people are only going to be able to actually understand at a given point of time a fraction of it. Now that there are, this looks a little bit bleak, but there are some mechanisms that are actually helpful. Even though we can see part of the data in a visualization, there are some cognitive mechanisms that allows you to process information visually faster. So one example of that is what are called pre-attentive features. So typically, if I show you something that is different from everything else in the display, it doesn't matter how much stuff you have in there, you're going to see it very, very quickly, typically in less than a tenth of a second. And that's the kind of thing that you want to use often to highlight in a graphic. So you'll see an example of that in everyday life. If you think at the maps, they usually use a pin for the location. The red pin for the destination and the green pin where you're starting at. And this is because these things are very different from everything else that is in the map, that are lines and other contours that depict the geography. And those you will see immediately. Now, this is not to say that that you always want to put dots everywhere, because it also depends on how you're using the display. If you're driving, it might not be very useful to just see dots. What you want to see is a direction, some type of arrows. So the arrows, they're also different usually, the way they're designed from everything else in the graphic. And everything is structured so that you can just take a glimpse and you understand in which street you need to turn without spending too much time on the display. Now, these pre-attentive features here, you see some of the characteristics on the slides. To detect them, you don't need to start looking around. You can just look at it and you'll see them. They do not require focused attention, which means that you don't need to stare at it for a long time and try to take them in to understand them. And they work on different channels. Typically, they work on color. So if you have a color that is very different than any other color that is used in the display, that will work. But they also work on shape. And the example is the one where you have a boundary. So if you have red dots and blue dots, these are blue, these are red. You'll see here a boundary that is very well defined, even though there is no boundary at all. I'm sorry, I'm this up. This is the picture that is in. These are putting them in a box. So these are red. Your visual system is such that you actually see the separation. There is no physical separation that is in the display, but for your brain, it's very clear that these things are separated. So these are. Even just displaying dots, you don't need to put an outline around it. Yeah, there is a link on the slides with a little video that shows this pre-attentive feature that you can look at. Let me finish maybe this slide because it's related, and then we'll take a break. Now, this thing, these attentive features work the same for everybody, regardless of age, ethnicity, and so on. As long as you have good enough eyesight, then they will work the same. There are other things that our visual system processes differently. And maybe the prime one is the color. So I've put there a picture that is kind of the extreme of this, that is that the different people see different colors. So most of the time you don't need to too much to be careful with that, but there are some categories of people that will not be able to understand what you're presenting to them if you're not careful. In particular, people who cannot differentiate red from green or colorblind. Yeah, so, and we're going to have just one class that is dedicated to color because it's a little bit complicated. Because colors are one way to show information. So I guess you're familiar with the so-called choroplexy map that are these colored geographical maps. Typically, what you see with the red and blue is the election maps. It's areas that are colored. So you can choose color scales that have to do with the value of the data that are encoded in each one of the geographical parcels. And the way you build these color scales needs to be, if you want it to work correctly, based on how your visual system is going to understand the values of colors as not to quantity. And the mapping is not linear. And so we're going to see this in some more detail. Okay, so I'll take a break here. We're slide 29, and I'll try to fiddle with this thing for 10 minutes at least. But if you have questions, I'm listening. Yep.
Is the quiz, will the quizzes and the percentage online be posted online for a person?
They're going to be online. There's going to be the first one is going to be in a week.
Yeah, you mean the quiz?
Yeah.
Okay.
So what I'm going to do is that I'm going to open it up for a day or two.
Oh, a day or
next
two.
Monday.
Okay.
And then you decide when you want to take it.
Okay. And it's like how many times will we open it? Like once we open it, will it be last 10 minutes or?
So each one that depends on how complex or lengthy are the questions.
Okay.
Yeah. Hello.
So I emailed you earlier. I'm Maya.
You're Maya, yes.
Yeah, and I was just wondering if there's any update on whether there's been any spots opening up in this class. I'm not technically enrolled.
So listen, what I know is that at some point we had 70, and they say I have several students who want in. Then we extended to 100, and they told me yes, we found another room. So this is the room. This one is only for 76. The roster right now on Blackboard shows 71.
Oh, okay. It's still saying closed on
And it does say closed, which I don't understand. I did tell the person at the department is looking at the things, but I think I shared with you. Did I ask you to try to email Lisa?
No, you said you were gonna email that.
Yeah, so I did it. So, yeah.
Okay, sounds good. So I'll just hang tight.
Yeah, but if you have some other recourse, you should give it a shot.
Is it pretty unlikely that I'll get into this one?
I don't know because at this point it seems to me that it's the room that is really defining the number of
I only
students.
asked
And today I wasn't even expecting there would be that many.
Okay, sounds good. I'll just
Yeah.
keep emailing you the reason
Okay,
I
cool.
need this class is for my master's, my PEP, because
Okay.
I'm still an undergrad and this is my last certificate course. So I'll just look back around every week until I have
Okay,
to-
cool. No worries. That was about the same question. So the situation is that I did give an okay to extend it to 100. Yeah, students, and currently it's 71. But when I said that, they told me we're giving you a different classroom, which I understood a classroom with more seats. Now this is the classroom which has only 76. So I don't know if they didn't find a larger classroom, and so they're going to cap it at that, or if they're still looking. I can try to ask, but it's going to become more and more likely. Yeah. I mean, it's your time. So if you want to come, you're welcome. But I cannot guarantee.
It's maybe change the classroom or wait for
Yeah, usually there are a couple of students that are dropping.
But for this week and next week, still in the same class.
Yes. Yeah. Yeah. Did you email me? Did you email me? No. Okay. Yeah. I mean, if you email me, I know about you, and then I can email you the slides and other things.
Because I did
Because if you're not in Blackboard, you won't be able to see the announcements.
what I already is given you the details.
You're waiting for the declaration.
Yeah, I'm already passed, but I didn't get it.
Oh, they say no.
It's still pending. I don't know.
Oh, still pending. Yeah.
It's not my turn. There's so many people.
Yeah. It looks like it's complicated this year. I'm sorry.
Thank you. And the share screen is like for everyone. I can add the share screen to share the meeting, the Zoom meeting. The slides. I can add the Zoom meeting. They like for everyone or the students.
Did you want the Zoom meeting? That's what you're asking?
Yeah, I can get in this.
Yeah, I mean,
meeting.
Yeah, you can get in, but you need to get the link from somebody. That's okay?
Yeah.
You know somebody to ask? No? Okay, but if you email me, because I did several people that are in your situation, they email me and I send them the link to email. Yeah? Okay.
That's why I really want to take this course, but I haven't been able to get the D clearance for it.
Yeah, it's the same question as there, yeah.
So, can something happen? It's my last semester. Maybe if you request the appointment, they might let you sir.
So yeah, I mean, I don't have a say really. The problem is the room. So as long as we want to keep it to in person, and you know, I don't mind doing hybrid if I can get it to work.
I can sit on the stairs.
But yeah, so it's the department to decide. I did give my approval to increase and to add another 30 students. But for some reason, the website is shows 70 and it shows that it's blocked. 14. Yeah, so yeah, let me ask, I can try to ask again to see what is the status, because I did email them saying, you know, the website shows that it's that it's locked. The room is only 76. What is going on? I didn't get an answer.
I'll email you to professor, so in case if it gets increased, then please.
Yeah, do email me so that at least you can get
The seat if it gets increased.
you can get the seat, but you can get also the links for the Zoom and
I have a
and
friend
the
who's
PDF.
sending me the link so far, so I'm following
Yeah.
you on this. Okay. Thank you.
Okay, good.
I'll email you.
Hello. So the quiz is going to be online, and I'll probably open it on Monday, 1 week from now, for a couple of days, and you go and you do it when you like.
It's the MCQ, right?
Yes.
So we can just do it within that time frame. And we'll post it. So we don't have to be here.
You need to do it when it's open. Yeah. And we're not going to do it in class because it's just lost time.
Right.
And I'm good enough at losing time with this thing, so I don't want to make it worse. You know,
The types.
yeah, I mean, if you have an idea, you're welcome to give it.
Can I reset this cable?
Yeah. No, so what I'm trying to do is get through Zoom. So each classroom now has a Zoom
Yeah.
connection, and I'm hosting the presentation. And okay, let me- Okay. So now it works. Exactly what I did for this document. I don't mind, you know, even giving Okay, so I guess I will start to thank you and then you take the name. Thank you for fixing the technology. I still don't know why how it works. Okay, so we started flipping at finish a little bit early and then take a look at the last. Okay, so here the rest of the slides we did just some generalities about data information visualization and some of the distinctions that we will make. So one of them is here is information visualization versus scientific visualization. So in information visualization and also data visualization, you can choose the representation. So you can, depending on your data, obviously, but you have multiple choices on how you want to show your data. And there are no good or bad ones, but there are some that might be more useful than others. In scientific visualization, you don't have the choice of the representation. This one, this is white matter brain regular chip. This is the person white matter. It's like that. You can try to color it. So your data for the colors that map to different colors depending on the domain here. An expert to be able to tell you that this, but you cannot change this representation. That makes sense. And so here is micro-oriented. So I say in terms of uses, people that work on user experience and design, they make the distinction between visual objects, what they allow you to do, and the sites that you can attach. So this is a moving walkway. So just by looking at the moving walkway, you know that it allows you to step on it and it will take you along. You don't necessarily know in which direction this is going. This particular one is glass sides. So if you don't have some signage with the topography here, it's very difficult. It's not very difficult, but it might be, you might see that if you're getting in the right direction and then don't get that information. So the affordances are the new actions that are possible, that means that you can work on these walkways. The signifiers are perfectly the iconography with the signs that tell you what is possible that you can do. So you can download the rail, you can go in a given direction but not in the other, and so on. So the main uses of visualization are summarized here. So there are usually two areas that people think of. The first one is communication of information, and the second one is the one that you're mostly interested is the analysis and modeling of the data. So depending on the scope, you can do different things. Maybe are some things that are related to it. So the action for communication, the action for communicate or explain, the action for analyze the model or explore, analyze the score, decide. And these speak of them in terms of I think that the data science pipeline, right? So the explore the data might do that in the acquisition phase. The analysis is just the analysis phase. Discovery is also part of the analysis phase. And the design step is really the decision making part as well. There you have some concrete examples of named visualization that correspond to each one of the use cases. So somebody was asking about the quiz. This is a quiz question. So you can go ahead and play. So again, these are just examples of visualization, so you understand how people use them in general. So and what they can do. So they're often used to explain some math that's done here, some geometry. And then you see that the formulas can be quite tricky to understand, but then the graphing, that's a nice job that explains. Here is the part that has to do with seeing patterns. So here you very quickly just look at the numbers. That's in here. You need to either sort them or scan them sequentially to understand which one is the largest, which one is the smallest, the distribution, and so on. But if you attach some bars, if you're going to put it in things like that, suddenly it's immediate. The longest one is fine, the shortest one is out there. And yeah, so the distribution is a little bit harder because it's not sorted, but you can obviously do that, and it will work the same. And when you have data and you look at the statistics of the data, then just the numbers usually that's not enough to understand the data that you're dealing with. And that is because the statistics are summary information on your data. And different distribution might have the same summary values. So this is a typical example that was put together by Hans Comte, that is a statistician, to describe this that. So all these numbers they have exactly the same thing, the same variance, and so on. I see the two lines in the regression line, they're all the same. But you see that the points are distributed completely differently. And if you don't graph it, you're going to end up saying that this phenomenon is the same as this one, which is obviously not going to be a good thing if you're doing some modeling. So there are some relations with the art world. Here is a good example, and also in terms of comprehension and supporting memory. So obviously, this is more for the information type of data and applications. Sorry, but it's often useful for people to remember some patterns. So if you want to graph them so people remember them, one way is to do what is shown here. So this is actually a field I'm going to talk about it later on. That was criticized for other reasons. I'm not going to play This one, this is from a video from Hans Rosling. If you get slides, you can click the link and go and look at it. But basically, is showing you with interactive graphics some data that if I remember well, to do with. Maybe I can play. Okay, play the right now. With income data in the world and how things get better over time, and being able to show different patterns based on historical events. So this is kind of big production from the BBC that was done in 2014 or so. That's roughly passed away 5 years ago. But the important point here is that it's a visualization that tells a story. And so, because it's complicated in terms of the information that you want to bring across, then if you want to do it well so that people actually can understand it fully, you want to bring it to a consistent story so that that offers a path to people and that helps understanding. So visualization are primarily there to tell a story. They can be used to inform, engage more diverse audiences. So here is the example of an infographic. So they're traditionally paper-based, but you can and you see them more and more in the form of interactive graphics in web pages. Think about newspapers such as the New York Times, the LA Times, or some of these, and then they explain different topics. So this particular one is the big data and the 4 Bs of the big data that you're probably familiar with. And let's look at the degree of information visualization. Whoops. So for those who again pay attention to the title, because that's really what it is about. So visualization needs to reach goals. So in this particular example here, the goal is to decide if it's better to rent or to buy. And so you have a set of visualization here in this page that we're trying to help you reach them. And most of the time, this is something that is equally applying to dashboards. So just think about the COVID for Johns Hopkins. So there are the goals that you get formed in terms of what are the patterns, different geographical areas of the spread, and so on. The information on the title, information on graphics, or infographics for short, are the devices whose aim is to help an audience complete certain tasks. So here you see a typical example. This is again from Nigel Holmes. This is the same guy who did the first graphic with the graphs with the diamonds. Now this is in terms of this typical information graphic that describes the fact that it makes it simple, that it's if you never folded a shirt, that it's a little bit complicated, and if you need to explain this to somebody, then the figure does it well. So all of these, the visualization elements, very simple and use that, are things that you want to keep in mind as you're designing it. And this is really a presentation. We're not talking about analysis, but what is most useful there is maybe the statistical graphics that you're going to be employing here is once you've done your analysis, you want to present it, being just on the data itself or on set of performance of the models, then you want pay particular attention to the way you design it, so that it's most efficient. So how do we design as human beings this visualization? So what we do is that we basically encode information. So we take the information that is revealed by analysis of the data, and we attach it to some visual form that encodes those data. And then the person who's going to look at this will need to decode it. So if you do it right, you're going to be able to decode it. Otherwise, there might not be, and then there is a gap there that is going to break the understanding of the person that is receiving the information. So in order to encode, you're going to use a certain set of assumptions that you make based upon what you know. And what you know is one data, so you're going to adapt the form that you're going to use to the data. If you have geographical data, you're going to pick some maps. If you think. And then assumption that you make in terms of the person who is going to use the data. What do they know about the graphic form that you're going to choose? So if you're looking at correlation between variables, you may use some plots that you are not familiar with. So it's important to understand how much the person at the receiving side is familiar with the form, how much they know about the topic, because otherwise you will need to present this information beforehand. There are abilities by default type. If you're using the wrong colors in your colorblind, we see some examples that makes basically photographing that is illegible. And then the characteristics of the display and how it's used. So that means is the person using non-dealt device, or are they sitting at the desk, are they driving, and so on. Right? Because in each one of these cases, it calls for different graphics to make the most efficient transfer of information. So when we talk about the first category, they are the form adapted. What you want to remember here is that the form should be constrained by the goals of the visualization. Right? So you don't start by saying, okay, I have some data, I'm going to do a bar chart. You start by saying, okay, I have some data, and I know that my goal is to show this thing from this data. And so what form is best adapted to it? Okay. So this is captured in this sentence here that says that form follows function. That is a principle that is coming from the architectural world. And in there, the idea is okay, I'm going to create a building and design it, but I'm going to do it based on what this use is going to be. I'm not going just to design randomly based on what I like, but I'm going to do it based on its usage. And so the form of the real thing follows this function. Okay, and this applies to exactly the same principle that is here to visualization. Okay, so the form follows the function, not the other way around. The function doesn't follow the form. And I think that that's it for the quiz part. I guess what's the most interesting. The tools and software. This is a little overview of all the tools and look at during the course. So what I did is that I put this paper from Jeffrey here from 2014 that creates this nomenclature of proposals, starting with chart topologies, visual analysis grammar, visualization grammar, component architecture, and graphic application. And then I've extended it with some of the toolkits that in addition at the time that we were going to. So the arrows here on the sides that have to do with the ease of use. Things are a little bit relative. And the expressiveness is how much how different the organization can you do with those. Okay, so if it's little expressive, then that you can only create easy bar charts. Line charts, if it's very expressive, then you have to add new visualization even if you want that you can invest. And so it's really a program you get if it's low level, then it's going to be more expensive because you can assemble the bits in different ways and end up with something original. If it's very constrained, it might look like build a bar chart with these parameters. If this is my data input, in that case, it's very expressive. But that plays on in terms of also ease of use. Usually, the less parameters you have play with, it's easier to use. And the other end, so with this display, the chart topologies are types of charts. So that means bar charts, like charts, etc. So all of these Google Sheet, like you see the same across the board, they use this idea that okay, I want this type of graphic, and they give you the functionality. Now with Google Sheet, you might, in itself, you might do it visually, but that's basically what you have a menu that allows you to select bar chart. Yeah, that's why we call it chart. The visual analysis grammar, so those are grammars meaning that you can instead of saying a bar chart, you can say I want this type of visualization that they build from this building blocks, and you do this as a sentence. And what these do is that they provide you with a way of separating the different pieces together in a quiet way, so that when you know how to build a sentence for one visualization, you can use that knowledge to build every other visualization. Yeah. And so typical example is that to do that, if we're going to, so that's what it does visually, where you try to config based on the graph. Typical tool does it by code. So it's structured, but it's really the same concept that is behind. One there is yet another market you see that is more recent. And also is a visual analysis graph. The visualization graphs, you see the difference between visual analysis and visualization. So these are tools that are kind of low level, lower or lower level, that allows you to create visualizations. And the graph right here is a little bit taken in a different sense. In particular, with difference, is just a library that we're going to use extensively. That is a JavaScript library that allows you to manipulate the data structure that we have in the browser, that is called dot, where you can put visual objects here to input your data, And so this is really an API. The grammar is at that step. Okay, so when here it's really the grammar in the steps settings and here. Component architecture, so these are we can actually see so those are originally were used on a desktop system where you had the jump and the interface to the graphics. And people developed for setting representation this toolkit here, so PPK, and that is now ported to the web. So we're going to go through that in that context. That is also because now everything is going for shot. And then the most complicated maybe the most common are the graphics application that are more 3D than 2D. So all of these are graphics that communicate. They're all usually used as 3D. So don't be free, you can use it because together. These are exclusively 3D. Seconds to be half. It's really 3D. So one of those things here on the WebGL is the OpenGL standard for browser. And it's basically 3D graphics, the stuff that you see in computer games. And obviously, you can do a lot with it, but it's a lot more complicated to use than just the things that deal with 2D space. Okay. And I'm going to try to give you some example application of that in visualization. So this is just a slide important piece to remember, but the hyper.js is, and I think I've already played around a little bit, but I'll go through it again. So it's a JavaScript library. It's client side, is it runs in the browser. So for those who are not familiar with the JavaScript warning, the JavaScript is the language that is used in the browser today. You have different implementation as the V8 engine, that implements this in the browser. And what it does is that it has the ability to create dynamic pages, basically. The browser renders HTML content, and then so the JavaScript allows you to interact with the HTML. The way the HTML is rendered, stored in a page and rendered, is in the form that is structured, it's called long, a document object content. And so everything within is a box that is put in a hierarchy. And so the JavaScript allows you in the browser to point this to the boxes, change your colors, change your properties, and so on. So that it does what you want to do. Now, this is client side. That is the browser, and what you will be by non-client side, the server side, yes. And there you might have heard of the ability to do a full stack application where you have the client that is implementing the JavaScript, but also the server that is also implementing the JavaScript. And that usually gets them oftentimes because you don't need to change language all the time. And in that case, what you have on your server is that you're going to run Ruby. That people as Python interpreters. So you at the command line you can type all of them. You have a JavaScript interpreter which doesn't have But sometimes it's useful to do to the server side rendering. If you want to render plots, that basically you have your data that are coming in, and then you want to re-render your plots, then you will do it on the client. And in that case, you would use a virtual DOM, which means that you use another library that is going to give you the data structure, and then you tell G3 go render here, and it's going to understand it. But the library uses lines like so between the three things, they are standard data in documents. It uses the recent HTML, SVG, and CSS. So HTML, you know what it is, the SVG is part of HTML is the scalable vector graphics. So that's a way to represent 2D objects, and then put them in an HTML language. The CSS is the style, this is the context, and this decides how you're going to represent your graphical object. Is the color, the line thickness, and so on, you can specify this CSS. So the difference is a library that allows you to take your data and put it into DOM in this form, SVG and CSS, and to manipulate those to make graphics. That's what's there. So what it does, obviously the data are usually in your drawing server. So what your client needs to go and get it. So the frame allows you to load the data in the browser memory. And it allows you to create SVG elements. So if you want to do a chart, it allows you to say that this value is going to be rendered as a bar. The bar becomes another block. So this fits the elements and bind data to the elements within the document. So when you see document things, document object on the data structure that's there. Transform and customize elements. So if you want to do transitions or change your bars to something like a pie chart, you can do it dynamically with if we approach you to do this with transformation effect and CSS. And the customization part is really good. If you want to highlight the data point, then you can go and change both. With D3, you can do that by querying the DOM tree and saying how this point needs to be read. And the transition elements response to the user input. So this is typically the example that you were seeing earlier in the web page where you add this interactive topic. Maybe I can show you. Here. So if I want to use this graphic, I'm going to comment this table down there and move it around and fix the problem. So if we allows you to do that, that's what it is. So you can handle events that are coming in through the browser and map them to changes in the graphic. I'm sorry, I'm trying. That's it. That's the last slide. That's it. We work here for 20. So we have 10 minutes. So what I suggest that we get started with the lab. Or at least you see what it looks like. And then we'll stop here. because maybe there is something here, so now you can start preparing this for Wednesday. So one of the largest impediments in this class is the coding and the developing in JavaScript. Now you can pick ways you can either decide that you're not going to do it, and or you start working on it and get to the point where this is not the way. Now it seems complicated, and it is. However, the amount of and the way you interact with the development environment that we're going to use is now. So we're not going to look at everything that you can do with verticals. We're just going to look at how to create graphics with this tool. Okay. So I know that a lot of people are already familiar with this, and you're going to find this boring. Those who are not familiar with it, you should really get along it and start using these tools in the way I'm going to try to explain it. And you'll see that very quickly that it's not that complicated. It gets complicated only if you don't have the right stuff, you don't know how to debug it, depending on what it is that you're working on. And yeah, I think that's the bottom line. So what I did in the past is trying to build up going from the easy bits to the harder things, little by little. Eventually, week 5 or 6, we get to complicated stuff, at least the most complicated stuff in terms of the graphics. This year, I'm going to try to do a little bit also the top to bottom way, so you see where it's going. So don't get scared if it looks scary. It's not that crazy. Okay, so in terms of developing for degree and so on, you want to make it as easy as possible for you. And so the recipe is to narrow down the choices. So these are the choices that I think are unexplained in this class. That means that you stick to one browser that is Chrome, that you have Node installed because that's the source of. When you install Node, you get the package manager is called npm that allows you to get defreeze and put all the JavaScript libraries on your computer in your home base. And then you want to use that with an ID that makes sense. So the one that I'm going to use is VS Code, Visual Studio Code. I know that some people do something different. If you're familiar with it, I'm fine with it. But this is, in my opinion, the best choice at the moment. So by Wednesday, if you can just go through the links and install these links. Yes. Some of them might be a little bit in terms of permissions. Not that it's the level of Node, but when you start installing it, packages, if you want to do it for the whole system, then you need permissions. So on backend, first you need to do a sudo for some of these. But we go for that. Visual Studio Code is a straightforward installation. So maybe we can take you from there Excellent. Now the homeworks and the labs are in GitHub. So you need Git installed. So depending if you in Windows or Mac, there are different recipes here that have listed. Hopefully you're already at that machine, so it's going to make it easier. When you deal with versions, so to permit your homework, you need to commit your work. So you can do this in Windows to look most of the time. I would say that the only reason to use something else like your desktop is maybe just to get the repository initially. If you don't want to use the command line, and then when you start working for the project and you're multiple people in the same repository, then it's easier to move that allows you to reconcile changes. These breaking changes. So this is the slide to get started with the assignment. We'll probably get to this week. Next week, next month, sorry. So it's again easy. Yeah, and then we're taking from there. I don't think there's much more detail. What I want to try to show you is how to use and just run some JavaScript. And oftentimes it's useful to use Node to process your data. If you're sending them to a browser, just because it's already JavaScript. And then some of the more complicated things also so simple with data thing. And then an application, a modern application, you don't write HTML pages like this, but you use like a framework. So I'm going to show you just a quick recipe of how to build a framework, and then we can use that for the project. Yeah. All right. Thank you. Oh, yeah. Oh, thank you. Ryan,
We actually are so confused about what class to take. A lot of other classes to do.
Yeah, you didn't take this one. Yeah. Yeah, because Ryan's related to this in New York. Oh, you're right here.
Are you?
So Ryan, he has the next grant research work. And so he's been working with